Good morning, dear students. Welcome back to physics class. Today, I would like to discuss on the topic streamline flow. This topic focus your attention on fluid in motion. The study of the fluids in motion is known as fluid dynamics. What are the different types of fluid flow? There are two types generally. They are first one streamline flow and second one turbulent flow. What is streamline flow? It is a steady flow of a fluid. When you turn a water tap slowly, you can notice the initial water flow is smooth, but it loses its smoothness when you increase the speed of the outflow by turning the tap again. The flow of a fluid is said to be steady if at any point the velocity of each passing fluid particle remains constant within that interval of time. Streamline is the path followed by the fluid particle. It means that the velocities of all the particles at any point are same at any particular instant of time. But you should understand the velocities of all the particles will not be same across all the points in the space. So, this steady flow is termed as streamline flow or laminar flow. The given figure shows a streamline or a path followed by a fluid particle. It is a curved line whose tangent at any point shows the direction of velocity of the fluid at that point. It is a typical trajectory of a fluid particle. Consider a case when all the particles of fluid passing a point A have the same velocity. This means that the first particle will have velocity v1 and second particle will have same velocity v1 and so on. All the particles will have the same velocity v1 at the point A. But at the point B, all the particles will have different velocity which is v2. Similarly, at the point C, the velocities of all the particles will be v3. We can see that the velocity is changing from one point to other point, but at one particular point the velocities are the same. No two streamlines can intersect. What is its justification? If two streamlines intersect each other, the particles are unable to follow a fixed path and to attain certain velocity at certain point. This will never happen. That is why no two streamlines intersect. Now, let us discuss on equation of continuity of a streamline and how can it derive. According to the equation of continuity, AV is equal to a constant, where A be the cross-sectional area at any point and V be the velocity with which the fluid flows. It means that if any liquid is flowing in streamline flow in a pipe of non-uniform cross-section area, then the rate of flow of the liquid across any cross-section remains constant. Consider a fluid flowing through a tube of varying thickness. Let the cross-sectional area at one end, which is P, equal to A1 and the cross-sectional area of other end, which is Q, is equal to A2. Then let us take velocity and density of the fluid at one end, which is P, as V1 and ρ1 respectively, and velocity and density of the fluid at other end, which is Q, as V2 and ρ2 respectively. Now let us see what is the volume covered by the fluid in a small interval of time across a cross-sectional area. At first, you have to see the volume covered by the fluid in a small interval of time delta t across left cross-sectional area at the point P, which is equal to area of cross-section at the point P into distance covered by the fluid in time interval delta t. Since distance covered is equal to velocity into time, which is v1 into delta t, where v1 be the velocity of the fluid particle at this point. So, volume is equal to a1 into distance covered is equal to a1 into v1 into delta t. Similarly, volume covered by the fluid in a small interval of time delta t across right cross-sectional area at the point Q is equal to a2 into v2 into delta t. As fluid inside is incompressible, which means that its volume does not change by applying pressure, then its density is remained unchanged at any point. Here at the point P and at the point Q, the density will be constant. So we can write as ρ1 is equal to ρ2, which is the expression 1. Since mass is equal to volume into density, so along the point P, mass of the fluid is equal to its volume a1 v1 delta t into its density ρ1. So, mass along the point P is equal to ρ1 a1 v1 delta t. Similarly, along the second point Q, mass is equal to ρ2 a2 v2 delta t. Since mass of the fluid flowing out is equal to its mass flowing in, which holds in all cases, so we can write as mass of the fluid along the point P is equal to mass of the fluid along the point Q. Then ρ1 a1 v1 delta t is equal to ρ2 a2 v2 delta t. From this expression, ρ1 and ρ2 are cancelled by using the equation 1. So, this equation will become as a1 into v1 delta t is equal to a2 into v2 delta t. From this expression, delta t's are cancelled on both sides. Then we get the expression in the form of a1 v1 is equal to a2 v2, which is the equation 2. This equation is called the equation of continuity of the streamline. From the equation of continuity, which is a1 v1 is equal to a2 v2, we can say that av is equal to a constant, which is the expression 3, where av gives the volume flux or flow rate and remains constant throughout the region of its flow. From the expression 2, which is a1 v1 is equal to a2 v2, it is clear that if a1 is greater than a2, then v1 is lower than v2. This equation is also termed as From the previous part, let us look into the concluding points. First point is volume flux or flow rate remains constant throughout the region. This means that rate of flow of fluid is more if area of cross-section is more, then its velocity will be less and vice versa. However, AV will be constant, that is, the product of area of cross-section and velocity of the fluid at the corresponding point will remain constant. Second point is the volume which is covered by the fluid at any cross-sectional area is constant throughout the region if the region has different cross-sectional areas. And third point is the fluid is accelerated while passing from wider area of cross-section towards the narrower area of cross-section. This means that if area of cross-section is more, the velocity is less and vice versa. Now let us discuss on turbulent flow. It is a second type of the fluid flow. What is turbulent flow? A fluid flow is said to be turbulent if the velocity of the fluid particles vary at any point erratically. You know that steady flow is achieved at low flow speeds. Beyond this limiting value, which is called critical speed, the flow will lose its steadiness and becomes turbulent. This means that fluid particles are moving with different velocities. They are not moving in organized manner. For example, when a fast flowing stream encounters rocks, small foamy whirlpool-like regions which are called white water rapids are formed. For example, when a fast flowing stream encounters rocks, small foamy whirlpool-like regions which are called white water rapids are formed. They are turbulent in nature. The given figures A and B show the streamline flow and the turbulent flow of fluids. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.